Hey there. So let's jump right into one of the biggest questions out there. What does it actually mean for something to be alive?
It sounds simple, right? You look at a rock and you look at a rabbit. Totally different. But why? What are the actual scientific rules that draw that line in the sand between the living and the non-living? Let's dig in.
All right, so think of this as our very own virtual field trip. We're going to gear up, and for the next few minutes, our mission is pretty clear. We're going to observe, understand, and maybe even classify some of the amazing life out there.
Okay, first things first. Any good explorer needs a checklist, right? You got to know what you're looking for. So what are those big, universal signs that scream, hey, I'm alive?
And here it is. This is our checklist. Pretty much every living thing we know about has these 5 core things in common. They grow, they need nutrition, fuel for energy. They move in some way. They respire, which is just a fancy way of saying they exchange gases to make that energy. And of course, they reproduce. You put those 5 things together and bam, you've got the engine of life.
Okay, so we've got our checklist. Let's start our field trip with the big ones, the 2 groups we all know and love, plants and animals.
You look at them side by side and the differences just jump out at you. One's stuck in the ground, the other's running around. But the why behind that, well, that's where it gets really interesting.
So here's the absolute game changer. Plants. They're basically little factories. They're producers. They take sunlight, water, CO2, and they make their own food. It's called photosynthesis, and it's a total superpower. The trade-off, though, they're pretty much stuck in one place. Now, animals, we're consumers. We can't make our own food, so we have to go out and find it. And that requires locomotion, the ability to move around. It's a huge difference that even changes how we grow. Plants can just keep getting bigger their whole lives, but most animals hit a certain size, and then that's it.
So see, it really boils down to this one big trade-off. Are you going to stay put and make your own food, or are you going to move around to find it? That one single choice is basically what defines these 2 massive kingdoms of life. Pretty cool, right?
Okay, but plants and animals are the obvious stuff. What about all the life we can't see? Our field trip is about to take a turn into a hidden world. It's all around us, it's even inside us, but we can't see it with our own eyes.
You know how this goes. You leave some bread out or maybe a piece of fruit on the counter and you forget about it. You come back in a few days and it's changed. It looks different. What's going on there? What's this invisible force doing its thing?
Well, the culprits are part of a whole other kingdom of life, microorganisms. We're talking about bacteria, fungi, all these tiny little living things that are responsible for stuff like decomposition. They're like the invisible cleanup crew and recycling team for the entire planet.
So yeah, the key thing here is they are tiny. So small you can't see them with the naked eye. Some you can spot with a regular microscope, but others are so ridiculously small, you need these super powerful electron microscopes just to know they're there. It's this huge, invisible world buzzing with life.
Okay, so we've got plants, we've got animals, we've got this entire invisible kingdom of microorganisms. That is a lot of different life, and that brings up a whole new problem. How on earth do scientists keep it all straight? How do they organize everything?
Think about it. Millions and millions of species. It's just a beautiful, chaotic mess. But luckily, scientists came up with this really clever, surprisingly simple tool to bring some order to it all.
It's called a dichotomous key. And I know that sounds super complicated, but the idea behind it is actually really simple. Dichotomous literally just means dividing into 2. It's basically a tool that plays a game of 20 questions, but every question only has 2 possible answers, like yes or no. So here's how it works. It's basically a process of elimination. You start with a big group of stuff you want to identify. Then you ask a question that splits the group in 2. Does it have legs? Yes goes in this pile. No goes in that pile. Then you take one of those smaller piles and do it again. Does it have wings? You keep splitting the groups over and over until you're left with just one thing. It's genius! Let's actually try it out. Okay, so we've got 5 different animals here. First question, does it have legs? Well, the frog, the dove, and the cat do, so they go over here. The cobra and the tilapia don't, so they go over there. See, we've already split the group. Now let's look at the no legs pile. Next question, does it have fins? The tilapia does, the cobra doesn't. Boom, identified. It's this super simple process that you can use to classify pretty much anything. So think about where we've been. We started with the 5 basic rules that define what it even means to be alive.
Then we looked at the huge split between plants and animals, dove into the invisible world of microbes, and finally saw the clever tools scientists use to make sense of it all. The sheer scope of the living world, it's just mind-blowing.
And that's a wrap on our virtual field trip. But you know what? The real one is waiting right outside your door. Every single thing we talked about today, it all started with someone just noticing something, with simple observation. So next time you're outside and you see a weird bug or a strange flower, don't just ignore it. Take a second, look closer, and ask yourself, what questions would I ask to figure out where this thing fits in the incredible, amazing, living world?